Okay, welcome back to the final exam review for Algebra 2. In this video, we're going to cover section 18, where we find the inverse of a given function. So, I think it's probably best to learn this by just doing examples. So, for number 247, we have that g of x is equal to negative 2x minus 5. So, in order to find the inverse function, what we do is we switch the x and y values here. So we know that g of x really just means the y value, and for convenience, I'm just going to replace g of x with y. So just rewriting our function like this, we have our y value and our x value. And again, what we want to do is we want to switch these two. So now I'm going to write x is equal to negative 2y minus 5. And now, all we want to do is solve for y again. So if I had to write steps for this, first, I guess optionally, replace g of x, f of x, whatever function you have, etc., with y, because that outputs your y value, or that tells you that that's the y value. And then switch the x's and y's. The third step is to solve for y. So here we saw step 1 in action. Here we saw step 2 in action. And now step 3, we're just going to solve. So we want to get y by itself. First thing we should do is add 5 to both sides. So we have x plus 5 is equal to negative 2y. And then last thing we need to do to get y by itself is divide by negative 2 on both sides. And so if we do that, divide by negative 2, divide by negative 2, the negative 2's cancel. And to keep y on the left-hand side, like we usually see it, we can write y is equal to just all of this. And we have x plus 5 divided by negative 2. So this right here is now your inverse function. Remember, we denote that with this little, it looks like an exponent of negative 1. It is not. And explained in the last video, it's just kind of a notation thing. But we have inverse of g of x is equal to x plus 5 divided by negative 2. And so now we want to confirm, is this actually our inverse function? So as mentioned in the last video, we can compose these, and we do g of inverse of g of x. And if we do that, it should be equal to x. So hopefully it is. But we can also confirm this with our graphing calculator. So we go back to a graphing calculator, and I have the same window settings as last time. So make sure, or I guess the best way to do that is go to Zoom, set it to Zoom Standard, and I only have the function y equals x graphed right now. But then also go back to Zoom and do Zoom Square, and it brings you to this this window. And this window should be fine for all of the problems that you do on your exam. But remember, if functions are actually inverses one another, they will be a reflection over this line. They'll make a mirror image. So if we go through and graph these two, we're going to graph this, and we're going to graph this. And let's see what we get. So for the first one, we have negative 2x minus 5. And for this one, remember to put in parentheses. If we want to put this one in parentheses, that is x plus 5 divided by negative 2. So x plus 5 divided by negative 2. And now let's see if they make a mirror image. They have one that looks like that, and one that looks like that. And so we can see that, yes, they do make a mirror image of one another. And so we know that this is correct. So this is our inverse function. So let's try the next one. We have number 248. Number 248 is, we have f of x is equal to negative 5 minus 1 over 5 times x. So this is our y, negative 5 minus 1/5 x. And now we want to switch our x and our y's. This is now x is equal to negative 5 minus 1 over 5 y. And now we just want to solve for y. So first let's add 5 to both sides. We have x plus 5 is equal to negative 1/5 y. And to cancel out negative 1/5, we multiply by negative 5 on both sides. So the reason that that happens is that any time you have something of the form 1 over a times a, this always cancels out because we multiply the a and the 1 together. This gives us a over a, and anything divided by itself is 1. Well, negative 1/5 is the same thing as 1 divided by negative 5. And when we multiply by, again, negative 5, that gives us negative 5 over negative 5, which is equal to 1, which is what we want to do. That's how we want to get a coefficient of 1y here. So by multiplying by negative 1/5 on both sides, this goes away. And over here we have negative 5x. Because we distribute this negative 5, we have negative 5 times x, so negative 5x, and then negative 5 times positive 5, which gives us negative 25. And that's going to be equal to y. And of course, to put that in a more familiar form, that means that y is equal to negative 5x minus 25. So now that y is isolated, we say that this is our inverse function. Inverse of f of x is equal to negative 5x minus 25. So let's see if that is actually our inverse function. We'll clear these two functions that we had, and we type in, for the first function, negative 5 minus 1 divided by 5x. And for the second function, we have negative 5x minus 25. And let's see what our graphs do. Okay, all right. And there we go. So these functions are inverses because they make a mirror image with their graphs, and they always intersect. When they do intersect, it is always along this black line here. This line, again, is y equals x. And so, confirmed, this is our inverse function. Let's look at the next one. So we have one more linear function. We have, for 249, f of x is equal to negative 5x minus 5 divided by 3. So let's just swap out this f of x for a y real quick. We have y is equal to negative 5x minus 5 divided by 3. And now we want to switch the x's and the y's. So we have x is equal to negative 5y minus 5 divided by 3. And now we just want to get the y by itself. So we can multiply by 3 on both sides first. That gives us 3x is equal to negative 5y minus 5. The reason that works is we have 3 times x over here, so that just simplifies to 3x. But we cancel out division So all of this is being divided by 3. We cancel out division using multiplication. So when we have 3 dividing by 3 times 3, those cancel out because they're inverse operations. And so that's why we're left with the negative 5y minus 5. But now, since we're still trying to get y by itself, we have to add 5 to both sides. We got 3x plus 5 is equal to negative 5y. And then dividing by negative 5 on both sides cancels out the negative 5s. And again, to write this in a more familiar form, we do have the y by itself. We have y is equal to 3x plus 5 divided by negative 5. And so we claim that f inverse of f of x is equal to 3x plus 5 divided by negative 5. And again, we can confirm this algebraically by composing these two functions, but if you have a graphing calculator with you, which you will in your exam, a quicker way to do that, you just have to make sure you type in everything accurately, is just to graph them and see if they make that reflection. So when typing this in, something to note is that you have to put in parentheses, we have negative 5x minus 5 divided by 3 if we're typing this in. We have to divide the entire numerator, so we put that all in parentheses, by 3. And for the other one here, again, we have to put the entire numerator in parentheses, so 3x plus 5, and then divided by negative 5. So typing those in, we have negative 5x minus 5 divided by 3, and then we have 3x plus 5 divided by negative 5. When we graph this, one function, the other, and we have our mirror reflection. And it looks like I dropped my pen. Okay, there we go. So confirmed, this is our inverse function. So let's look at a new type of function. These are all linear functions so far. What about number 250? We have g of x is equal to the cube root of x plus 2 minus 2. So first, let's swap out this g of x for a y. We have y is equal to cube root of x plus 2 minus 2. And now we want to switch the x's and the y's. So now we have x is equal to the cube root of y plus 2 minus 2. So before we can get rid of this cube root, we have to add 2 to both sides. We have to get the cube root by itself. We can't do anything on the inside of it until we do that. So we add 2 to both sides. We get x plus 2 is equal to the cube root of y plus 2. And now to undo a cube root, we cube both sides. So we don't need to expand this out. We can just leave it as x plus 2 cubed. However, since we cubed a cube root, all we're left with is what is inside the root symbol. So we have y plus 2. And now the only thing we need to do is subtract 2 from both sides. We have x plus 2 cubed is equal, minus 2. Minus 2 is equal to y. And so this is our inverse function. We can say, or we do say, that inverse of g of x is equal to x plus 2 cubed minus 2. So let's confirm that we have the right answer here. So clear out our two functions here, and let's type in the first one. So remember, to do a cube root, we do math, and we scroll down to the fourth option here. we have the cube root of x plus 2. Scroll out from under the root symbol, and then minus 2. And for the other one, we have x plus 2. Close parentheses. We use the caret symbol here, this little triangular, I don't know, peak mountain looking thing. Type in a 3, scroll out from under it, make sure you're not still up here, so you don't write this. So scroll to the right, and then minus 2. Graph it. We have one function, we have the other, and wow, look at that. Oh, what was that? Okay, there we go. So, we see this mirror image between the two functions, and so we know that we have the right function. So this is our inverse function. Let's look at number 251. So for number 251, we have that g of x is equal to x plus 2 cubed minus 1. Alright, so we have y is equal to x plus 2 cubed minus 1. So just switch out the g of x for a y, and now we're going to switch x and y. We have x is equal to y plus 2 cubed minus 1. And now we just want to solve for y. So before we can undo the cube there, we have to get it by itself. So we're going to add 1 to both sides. So we have x plus 1 is equal to y plus 2 cubed. And now we can get rid of that the cube here. And we can do that by taking the cube root of both sides. So if we cube root both sides, we have this cube root of x plus 1. However, the cube root of something cubed, you're just left with whatever is inside the parentheses, and you have y plus 2. And now the only thing we have to do now is subtract 2 from both sides. We have the cube root of x plus 1 is equal to, oh, forgot to subtract the 2. Minus 2 is equal to y. And since we have y by itself, we say that inverse of g of x is equal to all of this on the left-hand side, the cube root of x plus 1 minus 2. And so let's confirm, is this our function? So clear these two, and we can graph it. So first function we have is x plus 2, close parentheses, caret 3, and then minus 1. And the second function we have the cube root of x plus 1, so cube root x plus 1, and then minus 2. And let's see what we get. We graph. There's one function. There's the other. And we have a mirror image. So we know that this is our function. Alright, and last one for this video. For number 252, we have f of x is equal to the fifth root of x minus 2 plus 2. So even though this is a fifth root function, it doesn't really matter much. It's still going to cancel out when we raise it to the fifth power. So even though it looks a little bit different from what we've tackled so far, it really isn't that big of a deal. So let's just replace the f of x with a y. we have the fifth root of x minus 2 plus 2. And now let's switch the x's and the y's. Now we have x is equal to the fifth root of y minus 2 plus 2. So again, we can't begin to work with this yet until it's by itself, so we want to subtract 2 from both sides. We have x minus 2 is equal to the fifth root of y minus 2. And now we raise both sides to the fifth power. So in general, something to note here is that if you have, say, the nth root of anything, so it doesn't matter what a actually is, and it can be whatever you like, and we raise it to the nth power, this will always be equal to a. This always cancels out. And it's the other way around as well. What if we have, say, the nth root of a to the n power? This will also always cancel out. So just because we have a 5 here doesn't mean that we have to do anything too crazy. We're just going to raise it to the fifth power, and it'll cancel everything out. So we'll have our x minus 2 to the fifth power, because we had to do that to the other side as well. But this is now just equal to y minus 2. And again, we wanted to get y by itself, so all we need to do now is add 2 to both sides. We have x minus 2 to the fifth power every time. Plus 2 is equal to y. And so that means that our inverse function, inverse of f of x, is equal to x minus 2 to the fifth power plus 2. So let's confirm if we have the right functions. And let's see. So if you want to type in a root anything bigger than 3, you go to the fifth option, and notice that it has this little x for the index. So if you hit that option, it lets you, your calculator will let you type in any number you want here. So now we're going to type in a 5. And now we just have to scroll to the left, to the right. And we have x minus 2. Scroll out from under the root symbol, plus 2. And then our other function is x minus 2 to the fifth power plus 2. We graph this. And there we go. We have a mirror image. So we know that this is the correct function for our inverse. And that's how we do this. So to recap, and I wrote it on this page over here. So whatever function you're working with, just replace it with a y. Step 2, switch your x's and your y's. And 3, solve for y. So whatever result you get for your y is going to be your inverse function. And you can, of course, verify that with your calculator now. And so that's how we do this. That's all I have for you for this video. So thank you for watching.